should get phosphorus as being your, you should get phosphorus as being the excess reactant. Okay, very lastly, we're going to do another example of how we would calculate a limiting reactant as well as an excess reactant. But I just want to go through these few slides just really quickly. So the theoretical yield is something that will tell us the maximum amount of product that can be produced from a given amount of a reactant. So theoretical yield just means this is the most product that can be produced based on what I'm given. The actual yield is the amount of product that we're actually producing in an experiment. So there's a difference between actual and theoretical. And theoretical, of course, is what we would want to strive for every time in a lab. But stuff happens. Sometimes we get some product like on the sides of our beakers. Sometimes we can't get all of the product out of a little well plate. And all of those things factor into how much product I'm going to get. So if I were an awesome chemist and nothing ever went wrong, I would always get the maximum amount of product every time. That's my theoretical yield. But we're human and there's always error in a lab. We can't do something with 100% efficiency in the lab. So I will always end up getting something called an actual yield. And that's just what I'm actually getting after this chemical reaction has gone through. Based on the actual yield and the theoretical yield, we can calculate something called the percent yield. And the percent yield is just a ratio of the actual yield over the theoretical yield, and since it's a percent, we're going to have to times it by 100. So percent yield is just what I actually got in the lab versus what I could have made, what I could have produced in the lab, and then times 100. So let's say, for example, if the theoretical yield of a chemical reaction that began with 50 grams of a reactant is 25 grams of a product. So my theoretical yield of this product is 25 grams. My theoretical yield is 25 grams. I want to know what is the percent yield if I actually just got 22 grams of the product. So if I actually got 22 grams in the lab, but the most I could have gotten was 25 grams, I'm going to try to calculate my percent yield. So according to that last slide, my formula is actual divided by theoretical times 100. So my actual is 22, my theoretical is 25. So 22 divided by 25 and then times 100 should give you 88%. So we should get A. Okay, so now I want to do an example, another example with limiting reactants and excess reactants, just so that way you have another example of this. So let's say this is the reaction that you're given. You're given sodium phosphate is reacting with barium nitrate to produce barium phosphate and sodium nitrate. And let's say, suppose that 3.5 grams of sodium phosphate is mixed with a solution containing 6.4 grams of barium nitrate. I want to know how many grams of barium phosphate can be formed. So I want to know how much of this solid am I producing. And remember that the amount of that solid, the amount of barium phosphate I'm producing is based on the limiting reactant. So I have to figure that out first. So to do that, remember my first step. I was given the grams, I was given the mass for both reactants. So when I'm given mass, I'm going to convert that to what? Going to convert that to moles. So let's do that in both of these cases. Okay, so we were given 3.50 grams of sodium phosphate, and we want to convert that to moles of sodium phosphate. So I know in every 1 mole of sodium phosphate, there's 164 grams. So if I take 3.5 divided by 1.6, I should get 0.0213. That's moles of sodium phosphate. Okay, I need to do the exact same thing for barium nitrate. So I was given 6.4 grams of barium nitrate. I want to change that to moles. And if I look up my grams based on my periodic table, I would know that that is 261. And if I take 6.4 divided by 261, I'm going to get 0.0245. And that's moles of barium nitrate. Okay, so we've done step one. I had grams of both reactants. Now I have moles of both reactants. So that's my first step. My second step is to set up a mole ratio to get the moles of the reactants into moles of that product. Barium phosphate is specifically the one that I'm looking for here. So if I had, we'll just do one at a time. I had 0.0213 moles of sodium phosphate. And my goal is to get it to moles of barium phosphate. That's the product that we want to produce here, or find out how much is being produced. So moles of barium phosphate, set up my mole ratio over moles of sodium phosphate. Okay, if I look, barium phosphate has a coefficient of 1, so it's 1 mole to sodium phosphate, which is 2 moles. So I'd have a 1 to 2 ratio there. So this just becomes 0.0213 divided by 2, and that would give me 0.0107 moles of barium phosphate. Okay, well, I found the amount of moles of one of the reactants. I need to do that for the next one, for the barium nitrate reactant. So let's do the exact same thing, but we're going to do it for barium nitrate now instead. So barium nitrate gave me 0.245 moles. And now I need to set up a mole ratio. So again, moles of barium phosphate over moles of barium nitrate. Let's check our reaction. Barium phosphate, again, only 1 mole, so 1 will go on top. Barium nitrate has 3 moles, so 3 is going to go down below. So that's a 1 to 3 ratio. So now this is going to be 0.0245 divided by 3, and that's going to give you 0.00817. Okay, so my step now is to determine, let me write this one too, guys. My step now is to determine which one of these was my limiting reactant. Sodium phosphate gives me 0.0107 moles. Barium nitrate gives me 0.00817 moles. So which one of those is smaller? The 0.00817 moles is smaller, so that means that barium nitrate must be my limiting reactant. Okay, so now that we found our limiting reactant, we can find how many grams of this are going to be produced. So we just went from moles of barium nitrate to moles of barium phosphate based on using my limiting reactant here. So I'm going to take this number, 0.00817, and I'm going to erase everything up here. So that way we're just going to start working back up here. I don't want to erase that word yet. Okay. So I just found, according to using my limiting reactant, my moles of barium nitrate, I could produce 0.00817 moles of barium phosphate. And that was based on my limiting reactant. So if I want to know how many grams of barium phosphate I have, what could I do? I can go to molar, I can use molar mass to find the grams, to find the mass of barium phosphate, and then that would be the answer to my question. So I have 0.00817 moles of barium phosphate. Let's go to grams of that. I know that in 1 mole of barium phosphate, there's 601 grams. Big one. 601 grams. So if I took 0.00817 times 601, you should end up getting 4.91 grams of barium phosphate can be produced based on this reaction. So that would be my answer. Okay, so in the notes, we also did an example of the excess reactant, which is what I would like to do as well. So let's erase all of this. Okay, let's say that now the question that I ask you is how much sodium phosphate is going to be used in the reaction, and then how much sodium phosphate will be in excess. The reason I can say that sodium phosphate is my excess is because barium nitrate was my limiting. So that means this one must be what's in excess. So sodium phosphate, again, that's my excess reactant. I want to know how much of it will be used up in the reaction, and then how much of it will be left over after the reaction is done. So in the last part of this example, we calculated that we would have 0.0245 moles of barium nitrate. We found this number based on what we just did in the last part of this question here. If I want to know how many grams of sodium phosphate are going to be used in the reaction, I have to start with the amount of limiting reactant that I have, because this limiting reactant will limit how much sodium phosphate is actually needed in the reaction, and then that will tell me how much I'll have left over as well. So based, again, I found this number on doing this process up here. We found that we had 0.0245 moles of barium nitrate. I want to convert that to moles of sodium phosphate because that's my excess reactant. To do that, I'm going to set up a mole ratio. And the reason we're doing this is because I want to know how many grams of sodium phosphate were used in this reaction. Okay, let's compare our mole-to-mole ratio. 2 moles of Na3PO4 to every 3 moles of barium nitrate. So if we do this math, we should get 0.0163, and that would be moles of sodium phosphate. But again, I want to know not how many moles of sodium phosphate I'm going to need. I want to know how many grams of sodium phosphate are actually going to be reacting in this. So I can go from moles to grams by using molar mass. And grams would be 164. So if I take 0.0163 times 164, I will end up getting 2.68 grams of sodium phosphate used in the reaction. If I want to know how much sodium phosphate is left over, I started with 3.5, I ended with 2.68. If I subtract that, 3.5 minus 2.68, I'm going to get 0.82 grams in excess. All right, guys, so we've done an example using limiting and excess reactants. I'm going to post 2 problems that I'd like you to do for homework over the weekend with limiting and excess reactants. Bring those to class on Tuesday because we are off tomorrow. Woohoo! And I will see you guys on Tuesday, and I hope you have a really great extra day off. Bye!